Hello friends, welcome back to our channel. So in today's video, we'll be looking at the very significant weather event which will be unfolding in next 3-4 days, which will definitely going to bring intense thunderstorm over the southern peninsula India and some part of central and eastern India as well. So let's start analyzing this event from current satellite image, and we will see how how these conditions will going to evolve in incoming hours. So this is the any past 6 hours of satellite image animation from the windy app. As you can see that intense thunderstorm already started over part of Karnataka, Kerala, part of Maharashtra, and as well as over some part of Odisha and Telangana. So these thunderstorm activities are indeed part of some large scale circulation. So if you look at the equatorial region, if you just notice this region, you will note there is some kind of there is some kind of a cloud motion which is from east to west, and this is appears to be the extension of this equatorial convective activity. And to further understand why and how it is happening, we need to analyze the wind pattern, and together with the wind pattern, together with the uh, relative humidity. So let's close it and open the relative humidity chart that will give us more idea as to how the condition will evolve in future. So let me check where is the relative humidity here. So it's the relative humidity. So this is the relative humidity at surface. Uh, so as you might be aware that relative humidity is very highly dependent on the temperature. So the temperature is high, the relative humidity lower. So near the surface, despite you might have higher humidity, absolute humidity, you will have relative humidity lower because you have higher temperature. So that's why we have a low relative humidity over the interior part of southern India, but we have high humidity over the coastal region because of the simple fact that these regions usually have low temperature and significantly higher amount of absolute humidity. Now, if you let's move. So it is very clear if you look at just it very closely, it becomes very clear that there is a convergence of moisture from the Arabian Sea and Bay of Bengal. So just look into it. So here the winds are going this way. So there is a wind direction is this way. Here the wind direction are eastwards. So there is a convergence of wind over the western periphery of India, and that convergence of winds over that region is actually what causing the whole problem. Sorry, not the problem actually. This is what is causing the convergence and eventually the thunderstorm activity. And if we go a little bit up, let's move around. Let's move 3 kilometers up in the atmosphere. It will give you a beautiful picture. And so let's analyze it. So here we can see that there is a cyclonic circulation which is situated over southern peninsula India, and that this cyclonic circulation. Let's move a little bit lower for clarity. This cyclonic circulation is actually bringing moisture from the Arabian Bay of Bengal and advecting it toward the western Ghat of India and Maharashtra. And after the convection is happening here in the upper level around, let's see, the 500 hectopascal for example, you will note that there is a you know influx of moisture in the middle troposphere, and that influx of moisture is causing the low humidity over that high humidity over that region, perhaps because of the low temperature and moisture convergence. And that is why we have more clouds over the Maharashtra compared to it. So around 700 hectopascal, it looks very clear that most of these clouds which are happening over this region of India is indeed caused by the moisture advection from the Bay of Bengal toward the Karnataka, Maharashtra, Kerala, and Tamil Nadu state. And this is also reaching up to Madhya Pradesh and some part of Odisha, Telangana, and part of southern Madhya Pradesh. So yeah, this is the current situation as what we can see from these different models. So currently I am analyzing the ECMWF model. Now, let's see what we can expect, what type of weather we can expect. Let's start next few days. Let's start with the rainfall. So currently, as we can see, that there is isolated activity over different part of India. But tomorrow we will have little bit more intense thunderstorm activity over most part of Karnataka, Kerala, part of Maharashtra, and as well as some part of Odisha. By Tuesday will be a significant day for Karnataka. Flooding could also be possible over isolated region, and that is also extending up to the Maharashtra, even Madhya Pradesh, part of Madhya Pradesh. Chhattisgarh will also experience some thunderstorm activity. By 4th, it will continue over the southern peninsula India, and it will subside over Maharashtra. Uh, uh, and by 5th, it will will restrict towards the southern western part of India and southern part of India, and some part of east coast of India will also receive near Visakhapatnam and southern Odisha and northern part of Andhra Pradesh. By 6th of April, almost all of the rainfall activity will remain confined to the southern part of India, which is the Karnataka, Kerala, and Tamil Nadu. So this is by 7th, it will withdraw further, and one more system which will be moving from the Bay of Bengal toward the southern peninsula India will reach over the Tamil Nadu coast, and which will start raining from 8th or 9th of April. So it is still a quite long range forecast. So I think that we should be waiting for it to unfold a little bit, so that we will have clarity of how much it will going to impact. So let's wait for things to get a little more clearer, and then we will be able to discuss what condition which will unfold in near future. So yes, yeah, this is what we can actually get from this. So even if you look at the GFS, so currently I'm just animating the GFS. So I mean the picture is almost same. There is not much difference as far as the rainfall patterns are concerned, but it is lot more concentrated, a lot more more homogeneous compared to ECMWF. The formation of low pressure system is same in both ECMWF and GFS. So this is likely to happen with higher confidence. So it is unlikely that it will not have. It will definitely going to happen. So yeah, uh, yeah. This is. Let's see how it unfolds. So most of the rainfall. So let's see the total rainfall activity. It will give us more broader idea as to how much rainfall we can expect. So let's see the accumulated rainfall. Let's see for next 8 days, for instance, up to 15th. So the picture is looking somewhat surprising. Rainfall is starting from the Jammu and Kashmir, reaching up to northeast India and covering most part of eastern India and southern India. This is somewhat difficult to believe, but both model are expecting the similar scenario. So, but different intensity, of course. So let's see how it unfolds. I'm little unsure as to whether turn out to be true or not. It has to be looked into. Yeah, so this is, I think, all about the current weather system. So we can expect its impact mostly on the Karnataka region, which will experience some of localized flooding as well. Part of southern Maharashtra, uh, Telangana, and a part of Odisha will also experience this impact. Of course, the Tamil Nadu, Kerala will and Goa will also see a significant impact of this particular system. And Northeast India will also experience significant thunderstorm activity, but they are expected to be below normal. The thunderstorm activities are quite common in during this time over Northeast India, but so we can expect normal to slightly below normal activity. Yeah, so this is all about the current weather system. So I will be updating you with the most recent conditions as we move forward. So let's see how it unfolds. So tomorrow or maybe day after tomorrow, we will review again the situation, and we will see what are the expectations for the incoming western disturbance, and how this rainfall event will unfold. Thank you very much for watching, and I will see you in the next video. Till then, bye bye and take care.